Hey everyone, this is Rowan and Jonah, and today we're going to be going through different methods that you can use in Unity to create more dynamic and adaptive audio within your games. First of all, Rowan will deep dive in depth into how an audio source works in Unity and set them up to portray audio in your scene as well as in a 3D sense. Afterwards, I will go through audio post-processing, including how to add reverb zones, how to work with an audio mixer, and how to programmatically make your audio more dynamic. I'll hand it off to Rowan so he can begin talking about audio sources.
Hey guys, I'm going to tell you about how each component of the audio source works, and this will hopefully allow you to create more dynamic sounds in your games. So let's start off by pulling in this breathing sound effect I found off the internet into our scene. You'll see that an audio source is automatically created. The audio clip is the breathing. The output we don't have to worry about too much for now. Jonah will be explaining that later on. The mute button to mute the audio source. These three functions are pretty irrelevant most of the time, but if you're more interested in them, you can look under the Unity documentation. Basically, they just ignore these three things. Play on awake plays the audio source when the scene begins or when you hit the play button. The loop function allows you to repeat the audio clip over and over again, which we will do in this example. The priority, basically when you have more than one audio source playing at the same time, the audio source with the lowest priority is virtualized first. This is pretty irrelevant to us right now. We're going to leave it at 128 standard. We're going to pull the volume down to maybe about 0.5. The pitch we're going to leave. The stereo pan option allows you to change whether the sound comes from your left ear or your right ear. We don't need to change this right now, so we're going to leave it at 0. The spatial blend option for a 2D setting will let you, irrelevant of where the audio source is located, the sound will come from basically where you're standing. So these options here we'll be exploring later when I demonstrate a 3D sound effect. So for now, if we hit play, you can see no matter where we go, the breathing sound effect will be played wherever we are. It's a simple implementation of a 2D sound effect. Moving on to a 3D sound effect. So if you see over here, I got a couple of birds in my scene. We're going to pull in the bird chirping sound effect into the scene, and I'm going to try and pull it over to where these birds are. Okay, it's close enough. We're going to play on awake. We're going to put it on a loop. Leave the priority as 128. Pull the volume down, maybe about 0.5, somewhere around there. Leave the pitch. Leave the stereo pan. I'm going to make the spatial blend to 3D. This reverb zone mix, basically audio reverb zones are used if you want to gradually change from a point where there's no ambient sound to a place where there is one. So such as if you're entering like a cave, for example. We don't have to worry about that for now. So these 3D sound effects, there's the Doppler level. So basically this option changes if you have a player with a high velocity going past your audio source, for example, it'll change the pitch of the sound. The only way I can explain it is basically if you have like a car, you'd want to put a Doppler level up high so that you can have your car pass by your character and make that like car passing sound. So the spread basically allows you to control how much the 3D positioning affects the panning of the sound, so whether it comes from your left or right ear. The volume roll-off, there's the logarithmic roll-off, the linear roll-off, and there's a custom one. Basically, the logarithmic roll-off, if you're outside the zone of the audio source, you'll still hear it basically everywhere, unless you're very, very, very far away. The linear roll-off is what we're going to use in this example, and basically, the further you are from the audio source, the quieter it will get. So we actually have to set the distance of this as well, because right now 500 is way too big, and you'll hear it basically consistently. We'll be up here on the graph the whole time if we left it on 500. So let's pull it down to 5. 5 is this big. Let's pull it a little bigger. Maybe up to, yeah, about there. Looks good. There's our circle. That's how big our max distance is. Okay, let's try this out. Check the options. Alright, so right now you can hear our breathing sound effect, but not the bird sound effect yet. If we slowly approach the birds here, we can now just hear it as we're at the very edge of the linear roll off. If we move closer, you can notice how the birds get louder and louder until you're right next to them, and they're blasting the ears. Awesome. So that's basically how the components work for the audio source. I want to pass it over to Jonah now to explain how to implement this in program and how the output mixer works.
Thanks, Rohan. So my name's Jonah, and I'm going to be going over a bit more about the audio mixer side and the post-processing of audio in Unity. So Unity gives us a few tools to be able to process the sounds in our game a bit more than just having an audio source. And I'll go through a few of these tools now. So first of all, I want to take you through what an audio reverb zone is. An audio reverb zone is a type of game object that is physically in your scene. So you can add it to your game by going to the game object menu and selecting audio reverb zone. I've already got one in here. It's just in the middle of this building here. And basically, it's super simple. An audio reverb zone has a minimum distance and a maximum distance. So it's basically saying when the player is at least 5 meters away from this audio zone, start producing reverb on any sounds in the game. So if I press play here, you'll be able to hear the player walking just without any reverb or anything. And as I move into the house, you'll be able to hear some reverb start to be applied to the players walking. And then as I walk further away from the center of the room, it dissipates again. Now, what the minimum distance does in this equation is it basically sets how close the user has to be to the actual audio reverb zone game object in order for the maximum amount of reverb to be applied. So if I set this to 5, the same as the max distance, there will now be a sharp cutoff at the circle 5 units around the audio reverb zone. So if I walk in now, it goes from having no reverb to a maximum amount of reverb, and as I walk out of the room, no reverb again. Whereas if this is 0, then as soon as I get to the 5 meter mark, it will start applying a minimal amount of reverb, increasing as I get closer to the audio reverb zone. Alright, and the way to make a sound not be affected by a reverb zone is to click the bypass reverb zones section in the audio source. So now there will be no effect. But if I turn this off, you do get reverb. Okay, so that's reverb zones. Now that's all well and good, but what if I wanted to do more than just add a reverb to my sounds? And that is where the audio mixer comes in. The audio mixer is a section of Unity which you can view by going to Window and then Audio and selecting Audio Mixer. Basically, an audio mixer is a space where you can route the audio coming out of your audio sources that Rohan went through earlier. So if I go to Player Capsule and then down to the audio source, you can see that I've set the output as the player audio mixer group. You can't just send it to a whole audio mixer. It has to be to one of these channels, which Unity calls audio mixer groups. And in here, you can see that I have 3 audio mixer groups: the player, metal, and master, which is the parent of these 2. And basically what children and parents mean in the case of audio mixing is any sound that goes through either player or metal will also go through master. So since I have my player's audio mixer group set to player, any of the player's walking audio will also go through the master. So how does this help us? So basically on our audio mixer groups, we are able to change the volume of any of the audio sources going into that mixer group without needing to change each individual audio source. We can also add effects such as flanger, echo, pitch shifter, whatever you want. There's heaps of effects that you can add here, and that will affect every sound that goes through that mixer group. So let's show you an example. You can see that the master and player mixer groups are receiving some audio, which is coming from the player's audio source. Now, if I click Edit in Play Mode and bring the player's audio mixer group volume down to -20, you will see that both the master and the player group will be affected by the same amount. But if I bring the player back up to 0 and the master down to -20, you will see that even though the player group is receiving the volume straight from the player's audio source, it is then routing through the master and being ducked at the master stage. And even though this causes the same effect from the user's end, from a routing perspective, you can clearly see that the master is being affected, meanwhile the player audio group is not. Okay, so the next thing that I need to show you about the audio mixer is audio snapshots. Basically what snapshots are is, it's kind of on the tin, it's a snapshot of the audio mixer at the moment that you press this plus button. So any changes that I make to the mixer, as well as any of the effects, if I click plus, it will keep those values. And then if I go back to Walking Concrete and set these back to what they were before, you can see that if I click Walking Concrete copy, they go back to the snapshot that I just created. So I'll just delete that. So now we know how to make snapshots, but how do we transition between snapshots? And the way you do this is programmatically through Visual Studio. So first of all, you're going to have to create 2 public audio mixer snapshots in whatever your script is that you're using to control your audio sounds. So I've got Walking Concrete and Walking Metal. And then wherever your audio mixer is in the project manager, you can scroll down and find the snapshots. They have this icon, and basically just drag them into the snapshot areas in your script. And then it's super simple to transition between these. In my scenario, I've set it so that when the player enters a trigger and the other game object's tag is metal, I want it to transition to the Walking Metal snapshot. And this float in here is the time that it takes to transition or interpolate the values in your audio mixer between snapshots. So you can make it an instant change, so 0.1 F I've put here, or you can make it 5 seconds and the audio mixer will interpolate all of the values that are changing between the snapshots, which you'll see in just a moment. So let's see this in action. You can see in the snapshot section of the audio mixer, the starred snapshot is the snapshot that will be loaded by default. You can change this by right-clicking and setting as Start Snapshot in the Snapshots menu. And I will select the Player Audio Mixer group. And what I want you to keep an eye on is both the volume of the Metal Audio Mixer group, as well as the send level up here in the Player Audio Mixer group, as I step on this metal plate. So if I walk, you can hear that the audio has changed to more of a metallic sound. And if you look at the metal audio level as well as the send level in the player mixer, they interpolate at the rate that I specified in the program, so 0.1 seconds. And I'm not going to go through all of the different effects, but I do think that send and receive effects are quite useful and important to use. So if you'll notice, the player and metal audio groups are siblings. One is not a parent of another, which means that the audio from player is not being routed through metal or vice versa. They are both just going through master. But if I place a receive effect in one audio mixer group, such as in this instance the metal audio mixer group, and place a send effect in the other, so the player audio mixer group, and then I set the receive variable to metals receive, the player group will send any audio at this point in the effects chain to the metal audio mixer group at this part of the audio effect chain. And it will send through the audio at the level that is specified at the send level, which is why, even though the send is set up for the player to send to the metal audio mixer group, it is at negative 80 decibels, which is essentially silent, until I go over the metal and it's interpolated up to 0 decibels and the player's sound is sent through the metal audio mixer group. And that's why snapshots are so powerful, because I've got 3 effects set up here just on one audio mixer group. And they are all automatically interpolated between when you transition to a new snapshot. And you could have multiple different audio effect tracks, all with different values per snapshot, which can be changed dynamically using just one line of code. So it's extremely powerful. So that's how you use audio snapshots in an audio mixer. Although there is one other way that you can change audio programmatically, and that's by having another audio clip and then swapping that out programmatically. So if I come back to Visual Studio, you might have noticed that I also have 2 audio clips, which are Walking Concrete clip and Walking Metal clip. And these are 2 different audio clips that I've created. And I also have onTriggerEnter if the player enters an object with the tag metal clip, which you can see is this object here. Then audio source, which you can see in the player's awake function. I've set the audio source variable to the audio source component that is connected to our player. And we are getting that audio source and changing the clip to the metal walking clip and then pressing play. And then on trigger exit, it also changes back to concrete clip. So if we press play here, you can hear our walking on concrete sound. And then if we go over the metal here, you can hear the walking sound changes to a pre-recorded metal walking sound, and then back to concrete. So this is much more useful if you've already got the assets recorded. Maybe you've got some Foley or some stock sounds that you've downloaded, and you'd rather just swap out an audio clip with that sound. Alternatively, I would recommend using snapshots in any scenario where you are trying to affect more than just one audio source, or you are not trying to completely change the audio clip that is playing from an audio source, but more just how that audio clip sounds and how it fits into the world. And beyond that, being able to add a bit more room and space to your worlds is made much easier using a reverb zone. However, the downside of using a reverb zone is the reverb is not sent through an audio mixer, so you do have to edit each reverb zone separately. You could create a custom reverb zone just by setting X and Y coordinates programmatically and creating a reverb mixer channel and having an SFX reverb effect that you route through. But for a quick and easy solution, reverb zones are very helpful. So, what did we cover in this tutorial? First of all, Rohan went over audio sources in Unity and how to alter the parameters inside of an audio source to fine-tune a certain sound to your liking, and also how to represent the sound in a 3D world space. I then talked through different methods of post-processing which you can apply to your sounds, including audio reverb zones, how an audio mixer works, and how to transition through audio snapshots to create adaptive audio, and how to switch out clips within an audio source programmatically. I hope that this tutorial helps you create more dynamic and adaptive audio in future, and if you have any questions, feel free to drop me a message and I'd be happy to help. Thanks, guys.